01. Truth table. I will explain to you about the definition of truth table. Truth table is a diagram in rows and columns showing how the truth and falsity of a proposition varies with that of its components. T in the table stands for true statement, while F stands for false statement. If the compound statement has two variables, let's say P and Q, then the truth table must be constructed with 4 rows. It can be simplified into formula below, which is to the power of n, where n is the number of variables. Negation. Let P be a proposition. The statement "it is not the case of P" is another proposition called the negation of P, denoted by the negation P. Truth table for negation is when P is true, then the negation of P is false. We just inverse the truth value of P. If the P is false, then negation P is true. Example in form of English statement is P, Amir is hungry. Negation P, Amir is not hungry. Conjunction. Let P and Q be a proposition. The proposition P and Q, denoted by P with the symbol of and Q, is proposition that is true when both P and Q are true, then false otherwise. P and Q is called the conjunction of P and Q. Truth table for conjunction. When P is true, Q is true, then the truth value of P and Q is true. Then, if P is true while Q is false, the truth value of P and Q will be false. Same as when P is false and Q is true, or P and Q is false, then the truth value of them is false. Example in form of English statement is when P, Dia is smart, Q, Dia is cute. Then the statement of P and Q will be Dia is smart and cute. Disjunction. Let P and Q be proposition. The proposition P or Q, denoted by P, the symbol of or Q, is the proposition that is false when both P and Q are false, then true otherwise. P or Q is called the disjunction of P and Q. Truth table for disjunction is when P is true, Q is true, the truth value of P or Q is true. Same as when P is true, Q is false, or P is false, Q is true, then the truth value of them is true as well. But when both P is false and Q is false, then the true value of them is false. Example for in form of English statement for proposition or is when P, Amsha, wants to go to work, Q, Amsha loves reading book, then P or Q will be Amsha wants to go to work or he loves reading book. Implication. Let P and Q be proposition. The implication of P then Q, denoted by P imply Q, is the proposition that is false when P is true and Q is false, then true otherwise. P is called the hypothesis or antecedents or premise, and Q is called the conclusion or consequence. The truth table for implication is when P is true, Q is true, then the truth value of P imply Q is true. Same as when P is false, then Q is either true or false. The truth value of P imply Q must be true. But when if P is true and Q is false, then the truth value of P imply Q will be false. Example in form of English statement is P, Afrina is hardworking, Q, Afrina is smart. Then P imply Q will be if Afrina is hardworking, then Afrina is smart. Biconditional. Let P and Q be proposition. The biconditional statement of P, if and only if Q, P arrow Q is the proposition that is true when P and Q have the same truth values, then false otherwise. Truth table for biconditional is when P is true and Q is true, or P is false, Q is false, then truth values of P arrow Q is true. If otherwise, then the truth value will be false. Example in form of English statement P, Dayan eats candy, Q, Dayan got permission from his mom. Then P arrow Q will be Dayan eats candy if and only if he got permission from his mom. Example 1. Using truth table, determine the validity of given argument. Premise 1, P imply Q. Premise 2, R and P. Premise 3, negation Q. Conclusion P. Here, we have 3 variables, so we need to construct a truth table with 8 rows because 2 the power of 3 is 8. We construct P, Q, and R as usual. Negation Q. Negation of Q is just the inverse of Q. So, we get false, false, true, true, false, false, true, true. For P imply Q, as how I explained earlier, the proposition is only false when P is true and Q is false. Then it will be true otherwise. So we get true, true, false, false, true, 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 true. R and P. The proposition N is true when both R and P are true, then false otherwise. So we get true, false, 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 false. P imply Q and R and P. As I already explained, the truth value will only be true when both are true. Then we get true, then all false. P imply Q and R and P, and negation Q. We will get all false. Then P imply Q and R and P, and negation Q imply P will be all true. Since the final column is all true, that means it is a tautology, so the argument is valid. Example 2. Using truth table, determine the validity of the given argument. Premise 1, P imply R. Premise 2, R imply Q. Premise 3, negation Q. Conclusion, Q. Here also have 3 variables, so the truth table must have 8 rows. Then we construct the truth values of P, Q and R as usual. Negation Q. Just inverse the values of Q. P imply R. We get truth, false, true, false, true, 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 true. R imply Q, we get true, true, false, true, 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 false, true. P imply Q and R imply Q. As we know, it will only true when both is true and false otherwise. So we get true, false, 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 true, true, false, true. P imply Q and R imply Q and negation Q. We get false, 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 true. Then imply with Q, we get true, 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 false. In the final column, there is also false values, so it is not a tautology. Since P imply Q and R imply Q and negation Q imply Q is not a tautology, so the argument is not valid.
Okay, now I will explain about arguments in chapter 2. Okay, firstly, we will go to the definition of argument. First definition is an argument is a set of initial statements called premises or hypotheses followed by a conclusion. Based on this statement, it is clear that the argument must involve a set of initial statements. It means that it's involving more than one statement followed by a single conclusion. Second definition is an argument is valid if and only if every case where all the premises are true, the conclusion is true. Otherwise, the argument is invalid. From definition 2, it is clear that the validity of argument is depending on both statement, that is premises, and the conclusion. So, the argument will be valid if and only if both of the premises and conclusions are true. So basically, an argument consists of a statement or a finite collection of statements called premises or hypotheses and a statement called conclusion. An argument may be valid or invalid depending on the hypothesis. An argument is said to be valid if the conclusion is true whenever all hypotheses are true. Next, we will discuss about symbol, how to represent the argument using symbols. Symbolically, an argument is given as H1, H2, H3, ... 2HN or P1, P2, P3, ... to Pn, and it will lead us to a single conclusion only. Either we symbol it as H or P, where H stands for hypothesis and P stands for premises.
Now, we will look at the first example. How can we write this argument into symbolic form? If Faris has enough savings, then he goes for vacation. He is healthy or he has enough savings. He is not healthy, therefore he goes for vacation. First premises, if Faris has enough savings, then he goes for vacation. I write it as P1. Second premises, he is healthy or he has enough savings, P2. Third premises, he is not healthy, is P3, and the conclusion, therefore he goes for vacation, as C. Next, let's assume for the statement here. As we know, the premises or hypothesis is a combination of a few statements. So, we assume here statement P as Faris has enough savings, Q, he goes for vacation, R, he is healthy. Hence, the symbolic of the argument is P1, P implies to Q because premise 1 is an implication statement. P2, He is healthy or he has enough savings. That's why R or P. P3, he is not healthy. So we have the negation of R and it will equal to he goes for vacation, which is Q. Next is example 2. If Alia and Auni read the newspaper, then Auni will not watch the television. If Alia does not listen to music, then Auni will watch the television. Alia does not listen to music. For question A, write the primary propositions using the variables P, Q, R, and S. So P, Alia reads the newspaper. Q, Auni reads the newspaper. R, Auni watches the television. And S, Alia listens to music. Okay, B, we need to write the premises using the primary statement here. So we have P and Q implies to negation R. P and Q because Alia and Auni. Then P2 we have negation S implies to R. And P3 as negation S. For question C, firstly we need to do numbering for the premises that we have. P1, P2, P3 and then apply the rule of inferences to find the conclusion. So we have 2 and 3 as the modus ponens, number 5, 1 and 4 as the modus tollens, and lastly, use the De Morgan's law for number 6. And the conclusion is, Alia or Arni do not read the newspaper.
The forward and backward method. Proof is a convincing argument expressed in the language of mathematics that a statement is true. Basically, all methods of proofs are relying on the forward-backward method. Therefore, these methods will be the first attempt on a problem. The standard form of a statement is if A then B. There are 7 proof methods: forward, backward, construction, truth, specialization, contradiction, contrapositive, and induction. Definitions and mathematical terminology. M equals to Kn and divides M denotes as N divide M. If M equals to Kn for some integer K, M, and N, P greater than 1 prime if the only positive integers that divide P are 1 and P equals to 2K, N is even. N equals to 2K plus 1, M is odd. R is rational if and only if R equals to P over Q, where P, Q element to Z and Q not equal to 0. Isosceles. A triangle is isosceles if two of its sides have equal length. Number 1. If x, y, and z are 3 consecutive even integers, then x squared plus y squared equals to z squared. So hypothesis is x, y, and z are 3 consecutive even integers, and conclusion is x squared plus y squared equals to r squared. So how to prove it? We let x equals to 2p, y equals to 2p plus 2, and z equals to 2p plus 4. So it is consecutive even integers, so we plus with even number. So we get x squared plus y squared equals to 8p squared plus 8p plus 4, and out we get 4p squared plus 16p plus 16. Then we'll solve it and we'll find p. P equals to 3 and x equals to 2p is 6. Y equals to 2p plus 2 is 8. And z 2p plus 4 is 10. So r squared we get 10 squared. Then a7 equals to b. It is proven. Example 2. For any real number x and y, if x is rational and y is irrational, then x minus y is irrational. So we must use contradiction method because x and y is contradictory. So hypothesis is x is rational and y is irrational. Then the conclusion is x minus y is irrational. A1 not b is it is x minus y is rational. So if rational, we must use p over q, where p, q is element to z and q is not equal to 0. So A3 let x equals to r over s, where r as element to z and s not equal to 0. We must use this because it is rational. So x over y equals to p over q. So we substitute x, which is r over s minus y is equals to p over q. And therefore we get y equals to rq minus ps over sq, which is equals to a over b, where a is equals to rq minus ps and b equals to sq is not equal to 0. And a5, y is rational, so it is contradict with b. It is proven.
My name is ZAIRI bin ZAMRI, and I will continue with contradiction method. Why we use contradiction method? We use contradiction method because the forward, backward or direct method is not always successful. So we need to use this method to prove the question. And how and when to use this contradiction method. We use this contradiction method in proving by contradiction. Assume that A is true and B is false, or not B is true. Using the information in the process, we reach a contradiction. Therefore, in the contradiction method, we have two statements, A and not B, to reason forward. In general, we use the contradiction method when the statement not B gives some useful information. This happens in two instances. The first one is when B is one of the two possible choices. For example, B N is even and not B gonna be N is odd. And the second one is when the statement B contains the word no or not. For example, B M squared not equal to A plus B. For not B, M squared equals to A plus B. Okay, we're gonna go to example. And for example 1, the question is, if x squared minus 3x plus 2 more or equals to 0, then x less equals to 1 or x more or equals to 2. And your answer should have an analysis of the proof and the condensed proof. And for the analysis of the proof, the hypothesis and conclusion we're gonna take from the question. Hypothesis A is x squared minus 3x plus 2 more than equals to 0. And for conclusion B, x less than equals to 1 or x more than equals to 2. And the next step we're going to make not B, which is x more than 1 and x less than 2. The A2 we will make x minus 1 more than 0 and x minus 2 less than 0. After that we're going to combine those two. We're going to get x minus 1 times x minus 2 less than 0. And the fourth step, we will get x squared minus 3x plus 2 less than 0. Thus, x squared minus 3x plus 2 less than 0 contradicts the hypothesis A. And for the condensed proof, we assume to the contrary x more than 1 and x less than 2, which is the not B, and x squared minus 3x plus 2 more than equals to 0. Hence, x minus 1 more than 0 and x minus 2 less than 0 implies x minus 1 times x minus 2 less than 0. Therefore, x squared minus 3x plus 2 less than 0 contradicts the initial assumption. Okay, we're gonna go to example. And for example 1, the question is, if x squared minus 3x plus 2 more than equals to 0, then x less equals to 1 or x more equals to 2. And your answer should have an analysis of the proof and the condensed proof. And for the analysis of the proof, the hypothesis and conclusion we're going to take from the question. Hypothesis A is x squared minus 3x plus 2 more than equals to 0. And for conclusion B, x less than equals to 1 or x more than equals to 2. And the next step we're going to make not B, which is x more than 1 and x less than 2. The A2 we will make x minus 1 more than 0 and x minus 2 less than 0. After that we're gonna combine those two. We're gonna get x minus 1 times x minus 2 less than 0. And the fourth step, we will get x squared minus 3x plus 2 less than 0. Thus, x squared minus 3x plus 2 less than 0 contradicts the hypothesis A. And for the condensed proof, we assume to the contrary x more than 1 and x less than 2, which is the not B, and x squared minus 3x plus 2 more than equals to 0. Hence, x minus 1 more than 0 and x minus 2 less than 0 implies x minus 1 times x minus 2 less than 0. Therefore, x squared minus 3x plus 2 less than 0 contradicts the initial assumption. And lastly, for example 3, the question is, if A and B is the element of Z, then A squared minus 4B minus 3 is not equal to 0. So the answer for analysis of the proof, hypothesis A and B is the element of Z. And for conclusion B, A squared minus 4B minus 3 is not equal to 0. And for the first step, we're going to find not B, which is A squared minus 4B minus 3 is equals to 0. And the second step, we will get A squared equals to 4B plus 3. And the third step, we're going to get 4B plus 3 is odd. So A squared and A is odd too. And then A equals to 2n plus 1. For the fifth step, A squared equals to 2n plus 1 power of 2 equals to 4b plus 3. For n power of 2 plus 4n plus 1 equals to 4b plus 3. For n squared plus 4n minus 4b equals to 2. For in bracket n squared plus n minus b equals to 2. And n squared plus n minus b equals to 1 over 2. Therefore, A5 is contradict with A. And for the condensed proof, we assume to the contrary, A squared minus 4b minus 3 equals to 0. And A and b is the element of Z. Hence, A squared equals to 4b plus 3 implies to 4b plus 3 is odd. So, A squared is odd too. We're going to let A equals to 2n plus 1. Therefore, A squared equals to 2n plus 1 power of 2 equals to 4b plus 3. So, 4n squared plus 4n plus 1 equals to 4b plus 3. And 4n power of 2 plus 4n minus 4b equals to 2. And then we're going to get 4 in bracket n squared plus n minus b equals to 2. And lastly, we're going to get n squared plus n minus b equals to 1 over 2. Contradicts the initial assumption.
Conclusion. Symbolic logic studies some parts and relationships of the natural language by presenting them with symbols. The main components of symbolic logic are statements and connectives. Methods can be used to write proofs. Generally, there is no algorithm or procedure for proving theorems. However, it does not mean that proof writing is purely an art, so that only those with exceptional talent and insight can possibly write proof.